Let's start. Hi, good evening, everyone. Welcome to the Aspire with Prof show, brought to you by the Singapore Science Center, the Singapore Institute of Technology, and we hope that you get make sure that your mic is off so that we don't have a lot of background noise. Again, welcome, and today you can see that the format is slightly different, and we are not in our studio right now because of COVID-19, and we have certain safety measures, so we decided to do Zoom this evening. So again, welcome, and today we have a very interesting theme that a couple of what we call graduating students or graduate students comes together to form a team called initially called the fourth dimension, now changed to the fourth. So I say, may the force be with you. So joining us today is two of the three founders, Mervin and Abel, and I will hand over to them to introduce themselves and what are their technologies, what are their innovations, and what are they trying to do.
So, thanks for having us, Prof. Neo. So I'm Abel. So I'm leading the business side of FOR to help commercialize the whole idea. And joining me today is our technical founder, Mervin, who will be sharing with you more about our company in general, as well as what the technology is about and where it's heading. Yeah.
Thank you, Abel, for the introduction, and also thank you, Prof. Neo, for having us today. It's really a pleasure. So I think without further ado, I'll just begin. So good evening, everyone. My name is Mervin, as Abel has mentioned, and we want to introduce to you what our venture is all about, right? FOR. But before that, I want to also introduce like some kind of background behind what we aim to do and what FOR is really about. So yeah, so our technology so basically what we want to do is to reshape structures. So what do we mean by that, right? So I'm sure in the realm of manufacturing, you have heard of this emerging technology called 3D printing, right? Right. And when you hear about 3D printing, what kind of products do you usually think are made from this process? It's usually like prototypes, right? Iterative prototyping. So people usually generate like 3D print files and then print their objects exactly as they are, basically like static structures. They are just printed as it is, right? And most of the time, even you admire the parts that you print like just for a few hours or few days, and then afterwards it's basically just a paperweight. So what really drives our research and innovation is this concept of active or dynamic structures, right? Structures that can morph. So with this in mind, let me talk about like two key aspects of structures like this that is behind this interesting phenomena. So the first aspect is the material itself that's used for these structures. So there's this increasing interest in this field of smart materials or polymers, which usually portrays this shape memory effect. So this is the sort of the fundamental aspect behind what people term as 4D printing, which is basically what our name is derived from, 4D printing. So what is 4D printing? So you know what 3D printing is, right? Basically, you deposit material in this three-dimensional space in the X, Y, and Z planes. So now they introduce this fourth dimension, as they call it, which is time. So now I know there are a lot of you probably have your eyebrows raised, but honestly, I'm not too keen in this description as well. But it's defined by this person who came up with this name 4D printing, Skylar Tibbets. But 4D printing, it grabs attention. So what happens in 4D printing is that due to this material's unique property, right, they actually respond to environmental stimulus like heat, light, magnetism, and so forth. And because of this response from this stimulus, the structures bend, shrink and deform to change its shape or function over time. Like this example on the top right corner of the slide, where this flat black sheet of plastic starts to bend at the edges to become a cube. Yeah. So maybe I can just give you like an example of what kind of research that 4D printing is looking at. So in this example, at the bottom, we see these shape memory balloon structures that are actuated by heat. So one thermal property of materials is glass transition temperature, right? TG. So usually a material has a melting point, right? Where it basically transitions from a solid to liquid state. And then there is this glass transition temperature within the solid state itself, where the material transitions from a glassy or rigid state to a rubbery or flexible state. So these researchers use this multi-material printing to distribute the materials of different TG values. As you can see, there's a TG1 and TG2 within a structure. So what happens is by heating this structure, this overall structure to a temperature between these two glass transition temperatures, one of the material actually becomes rubbery and malleable, or the other is rigid, right? And because these structures are printed as a tubular structure, right, by supplying like pneumatic forces or air pressure into this structure, the softer material actually expands like a balloon. And then when it expands and you cool the overall structure down to below the glass transition temperature, it actually becomes rigid again. So if you remove the air pressure, the structure stays expanded. So this is like the fundamental mechanism behind this multi-material shape memory balloons, where you create like this kind of balloon hinges, and this induces these forces that causes this overall structure to bend and warp according to how these balloon structures expand within the structure itself. Yeah. So I roughly talk about this first aspect, right, which is the material property itself. So there's this other aspect of structures that allows for a more controlled deformation, which is essentially the mechanism behind controlling this range of motion, right? So, Prof. Neil, I'd like to ask a question. So, when you stretch a material, let's say your clothes, can you describe like how does it usually behave?
Well, depends, right? Whether it's stretchable fabric, right? So
Okay.
normally it will just extend a little bit, right? Because of the elasticity of the material.
Yes. So when you say it extends, does it extend like uniformly, or is it just the direction where you stretch?
It's the direction that you stretch, right? Because it depends on the forces. Yeah.
Yeah. Then what about the sides, like beside where you stretch? What happens to it?
That's interesting. Maybe I'm not sure whether it compressed or not, but it stretched, right? Then the other side will come in, right?
Yes, exactly right. This is usually how materials will behave when you stretch a rubber band, for example. You apply a tension and the other part contracts. That's usually how we observe materials. So there's this interesting structure called the auxetic structures that utilizes this that is basically inspired by kirigami. I'll talk about kirigami in a bit. But basically the idea is to, instead of having the side contract, it actually stretches uniformly, expands, have this isotropic expansion throughout the structure. So that's the idea behind auxetic structures. So like I said, it's inspired by kirigami techniques. So kirigami is basically a variation of origami. You know, origami is basically folding papers, right, in different ways. Kirigami is basically you cut slits on the paper and you stretch it, and it also like have different kind of deformation. So basically this is how an auxetic structure behaves. when you stretch it, it actually expands uniformly. And then I want to tell you about this problem of auxetic structures, right? When you stretch, and then when you release the tension, it actually goes back to its original shape, right? So this researchers look at bistable auxetic structures, which means that when you stretch the structure, it expands, and then when you let go, it still stays expanded. So it's very interesting, right? Usually when you release something, it actually goes back to its original state. But you stretch and you release, it stays expanded. So this is the this is talking about bistable mechanisms. Basically, you achieve a secondary state of equilibrium for the structures that you design. So how this works is basically, yeah. So basically, this researchers design like this unit cell, which is a hexagon with like slits along the edges and cut like these triangles. So when you stretch it, these triangles actually rotate. The material is actually rubber, so it's very flexible, so it doesn't break at these points. And then when you rotate, and then the gaps along the edges actually touch each other over here, and then it stays stable at that state. So this is like the idea behind bistable auxetic structures, and they design like this. They design like this structure, which honestly looks like a bra, but yeah, they design this structure that has different expansion ratios throughout this structure. For example, towards the corners, it actually doesn't expand as much, but the others, around the area, around the center, it actually expands much more. Yeah, so this is like an example of this kind of mechanisms that allow for these reshaping structures. Another example I want to talk about is this idea of two-path planning. So when you talk about 3D printing, right, or any manufacturing process, there's actually a lot of steps behind it, and how you control this manufacturing process can actually result in certain structures with more controlled properties for the structure. So in this example, instead of, usually when you 3D print structures, they have like a very homogeneous, uniformly distributed infill, the material. And what they did was they changed the two path of the printing method itself to allow like some parts to be more rigid, like on the right, and some parts to be more flexible. Right? And yeah, so this is basically the process behind how they design structures that are not uniformly rigid or flexible. They can control like which parts will have a direction of rigidity and directions of flexibility, and they call this the rigidity contrast gradation. So this is like the mechanism behind it, and they demonstrated like with this minuscule 3D printed knee that is flexible at the parts where they need to bend. Yeah, which is the knee itself. Something like this. Yes. So by showing these mechanisms, I hope like I have given you like a background of the direction of our research behind programming structures, which can be transformed for functional purpose, not just like fixed static structures. I think Abel, you want to continue from here? Abel, you are muted.
Yeah, sure. So thanks, Mervin. So maybe I can share a bit about the current challenges in programming structures right now. So at the current stage, right, the manufacturing time of programmer structures take very long, because as you know, 3D printing might even take a few hours to print out one single structure. And at the same time, this severely affects the scalability of manufacturing these structures, along with the fact that the size of the printer will also affect the size of the possible structure. At the same time, it's actually very difficult to precisely design how you want the structure to actually morph, because of, there's a lot of factors that you have to take into account, both internal and external. At the same time, that actuation force itself comes with its own risk. For example, if we are using heat to change the structure, the heat force might not always be controllable as well. So this is why, we created FOR, because our own proprietary method actually makes the designing of programmable structures more intuitive and more precise and more scalable. So currently this method is actually actually pending a patent. So yeah, we're waiting for that right now. And then, overall, our direction is to aim to introduce these morphable structures to improve everyday life. Then our long-term goal is actually to be the global leader of physical design and manufacturing technologies. So with this in mind, our first application of this technology is actually on orthopedic casts, which we have dubbed Customize. So what exactly are we solving with Customize? So let me introduce you to Mao. So as you can see here, he broke his arm as a child, maybe playing some games and being silly. And, the plaster cast has to be put on him to help him heal and to recover his tissue. However, this cast actually comes with a lot of inconveniences and problems as well. So yeah, if any of you have put on a cast before, you guys would know that, there are a lot of problems. For example, that you're in constant fear of contact with water, as having water in it might lead to a lot of complications. And because there's a very poor ventilation within the cast itself, it tends to get very itchy, and yet at the same time, frustratingly, you cannot scratch it at all. And at the same time, these casts are actually very bulky. They can weigh very heavily, and it can impede your everyday activities very severely. On the flip side, on the doctor's point of view, there are a lot of problems as well. So let me bring you to an example of Dr. Dave. Next slide, please. So for Dr. Dave, he's an orthopedic surgeon who has to encounter a lot of these kinds of fractures. And then, for him, he has to apply the cast. After applying the cast, he has to observe his patients every few weeks to monitor the healing process. This can cause him to have to remove the cast every 3 to 4 months for inspection before being cleared for rehabilitation. However, at the same time, in these stages, these processes are actually very tedious. You have to use a lot of different tools and multiple steps to apply and remove this cast. And at the same time, because the casts are not transparent, you can't really see what the healing process, the healing progress is like. So you have to go and remove it. And let's say when you remove it, if the wound hasn't fully healed yet, you have to reapply it again. And at the same time, while removing or while wearing the cast itself, there can be a lot of complications such as cast burns or compartment syndrome. So to overcome these problems, we have come up with our own series of casts, customized. So this is our proof of concept solution, which is actually starting with a finger cast. Currently, we are developing the wrist cast as well. So as you can see here, some of the benefits that we have is that our material is actually fully waterproof, and it's actually much lighter compared to the traditional cast that you see out there. At the same time, there is a lot of there's improved ventilation, and then this leads to about 6 degrees Celsius reduction in the surface temperature. And studies have shown that these attributes actually help wounds to heal faster. Yeah, next page, please. So maybe I can give you a brief demonstration of how this will actually work. So through our proprietary method, the structure is actually fabricated as a flat sheet of plastic, making it possible to be easily manufactured and scalably manufactured. So the flat sheets are softened upon heating, and then after it can be applied, and then thereafter it will be waterproof and light, and then it provides rigidity as well. So it's also very easy to remove this structure. You just have to heat it up, and then after that, it will naturally become a flat structure again. Yep. So for the clinician side, it is very easy to inspect the wounds as well. So maybe you can compare it by, with the existing cast out there. So as you can see from here, we are actually, we have a lot of benefits in many areas, even with more emerging technologies such as open cast, where we are still able to have the least amount of instruments needed, and at the same time we are also able to remove the cast, and then after we can adjust the size, and then we can put it back in again. Because as you know, sometimes with all these kind of fractures, swelling may occur, so there is some need to change the sizes of casts at times. Yeah. So let us look at some of our go-to-market strategies for our own cast. So we are actually going to start with Singapore, where we are currently discussing with hospitals here on launching clinical trials with them, and then thereafter we'll be moving to other regions in Southeast Asia before moving towards the global market. So for the go-to-market strategy itself, we actually stem it from two possible product lines, from this same research, which they share similar design and yet they serve different purposes. So actually the main product of ours is the brace, which immobilizes the bones, while guards are meant for the sports industry and meant for support. So we identified two target groups of the elderly as well as the athletes who have greater need for this kind of products as well for their faster recovery. So the main channels that we are considering now and looking into are Western medicine hospitals, but on the secondary channels, we have things such as TCM clinics, as well as for athletes, we have rehabilitation centers. So to visualize what this whole plan might look like, so currently, braces are very low-risk medical devices under Class A/Class 1 categories for the respective regulatory bodies around the world. And then at the same time, as guards are meant for support, we don't really have it for medical purposes, which gives a shorter turnaround time for the certification approvals. So after the pilot trials and exposures, we'll be able to launch both products pretty closely at the same time. Yeah. So let me run through about our progress so far. So, with our prototypes, we have run through some interviews with some stakeholders, and we have met with a lot of positive feedback from parties such as TCM clinics, as well as orthopedic surgeons. Yeah. So, yeah, currently, next slide, please. Currently, we are in the midst of securing pilot trials with hospitals such as CGH and a TCM clinic, where we have demonstrated the incorporation of, TCM acupuncture, the possibility of it with our own cast as well. So, we've also signed a LOI from a prospective customer here, Clinic Teo. Yeah. So last but not least, I would like to introduce to you our founding team. So it comprises of Mervin, myself, and Jai, and we are respectively leading the technology, sales and marketing, and operations. So lastly, of course, we are joined by our technical advisor, Professor Michinau, who has been, guiding us throughout our development as well. So yeah, in summary, to conclude, our technology uses programmable structures from technologies such as 4D printing to fabricate these rigid yet morphable structures for different users, where, our first industry and applications actually for orthopedic cast. So for this brand customers, we are actually currently looking for more clinical trial partners, distribution opportunities, and investments. And yeah, feel free to contact us if you are interested in working together. Yeah, thanks.
All right, thank you. So this is very interesting because it's really a commercialization of a piece of technology that most of people, after explanation by Mervin, still don't understand what it is. Yeah, I know that you're trying to make it as simple as possible, but this is an interesting theme, right? Because I see that Mervin, you do your research in SUTD, and Abel is from SMU. How do you manage to get together?
Right. Yeah. So we actually met from our mutual friend Mao. Yeah. So Mao was actually with Mervin SUTD. So yeah, Mao got in touch with me because he knew that I was interested in entrepreneurship, and then yeah, we found that we could work together to commercialize this idea together.
Okay, great. So let's talk about when we have a technology. Then the next question is finding the problem to solve, right? So why you choose these braces first?
Right.
Why this
So,
application?
yeah. So if I'm not wrong, I think it's because Mervin, he does a lot of mountain climbing, so he has experience, breaking his limbs. So that's why, he thought of having this application first.
So Mao, right? Mao, right? Is it
Yeah,
Mao?
yeah, Mao.
Yeah. So Mao is the persona, right? So he's the guy who has the problem, and then he applied the technology for himself. Okay, then you have a really good case study, right? So, while in trying to conceptualizing and trying to design this, what are the challenges that you're faced in bringing the technology to basically come out with a prototype and then defining it as a business? Is it a good business to enter? I mean, yeah, you don't done your total addressable market, but how confident you are? How do you research that this is real?
Right. So maybe Mervin can share a bit more about the whole prototyping process.
Okay. Yeah, thank you. Thank you for the question. Okay, I guess maybe I can give you like a bit of a background. So actually we prior to this, like prior to implementing our research into this project, we actually tried to develop our own 3D printed cars before, as you see in this image on the right. Yeah, over here. Yeah, so that was dated, I think 2 or 3 years back, or even earlier. I can't remember. Yeah, so basically it was part of our module in SUTD. We developed a orthopedic cast that is essentially 3D printed, right? So I think just now I roughly talk about 3D printing itself. What are the problems there are? So maybe I'll just reiterate again. So like when we printed the cast as it is, right, in a 3D structure, not as a flat sheet, we actually need to first thing, there's this requirement of support structures, because when you print in 3D, if there's any overhang, it actually, the gravity will cause it to collapse. So you need like some support structures, and then this basically requires much more time to process this manufacturing process. And then secondly, because this 3D printed cast is meant for immobilization, right? So it needs to be rigid. So basically, you cannot print this whole cast in one piece and then like just put it on like a glove. You need to print it in like two or more parts, and then you have these joints that you need to that just brings additional cost and time for assembly. So I think the whole idea behind like why we actually stopped this 3D printing direction for quite a bit, which sort of prompts me into this research direction to look at alternative ways where we can manufacture in a more efficient way that solves this kind of problems. So I think that was like the direction for the prototyping.
Yeah. So for your second question about why we are confident that we'll be able to commercialize this, I think it's because we know that we are kind of addressing a real problem when we give organizations a call about the properties that our cars have. Most of them, they are interested in meeting further and discussing further. So most of them are right now just eagerly waiting for the further progression on our prototyping, which will be done pretty much soon. Yeah.
Okay, thank you. So if I will ask the question first, and if the audience have any question, you can type in the chat room, and then I would redirect the questions. Huh? So the thing right now is that this is a medical product, right? So how do you go around seeking help and trying to determine that this product will get approved? How much knowledge you have? How do you tap other people's knowledge? How do you structure that?
Right. So, one of our founders, who is in this room now, Jia Yi, so she's actually undergoing a PhD in medical engineering, something like that. So yeah, she's very, you know, she knows the regulations well. So yeah, we are blessed to have a founder like her. And at the same time, you know, we have also consulted with some doctors about, you know, how what kind of problems we might face. Yeah.
Okay, I think Jia has joined yeah. You want to say something?
We cannot hear you.
Maybe yeah, we
Oh yeah.
yeah, I think okay, we need to unmute you, right? So
Oh, I think you can try speaking.
Hey, hi. Can you hear?
Yeah.
Hello?
yeah, we can hear you.
Yeah, okay. So we're also talking to some regulatory agencies, and we are glad that we actually fall under class 1 medical product and also class A. So in terms of regulation, it will be less strict as compared to higher risk medical products.
Okay. So I believe that your first market is Singapore.
Yeah.
Why do you choose? Why do you choose Singapore? Is it because regulatory is easy, or it is? But it's not a very big market, right?
Yeah, I would say mainly it's because, you know, it is our home ground. It's easier to try to get things started.
Actually, we plan to go.
Yeah, go ahead.
Oh, okay. We plan to go for regulation from, as in we want to gain.
I think she's stuck.
Yeah, her connection is
both
probably...
FDA and HSA, but it's just that would be easy.
Yes, Jai is a bit connection is not very smooth, right, over there. Okay, maybe you can type it out to get the answer. Now, but I think you're okay. So now you're a relatively young team, and some of you are studying. So you know, how do you convince people to invest in you?
Convincing people to invest. I would say, you know, I think recently we have gotten one of the GAP funding grant. So yeah, that's pretty one of the bigger ones from Singapore itself. And you know, we are also currently in talks with some venture capitalists as well. So I would say, as long as we are able to show that there is a value and show that the business model is viable, like the benefit, the profits definitely outweigh the cost. You know, they will be more than willing to, you know, lend us a year, which has been the case so far. So I think, yeah, of course, you know, it's very important to keep trying and reaching out to as many people as possible. So I think for every 10 people we reach out to, maybe only 1 or 2 actually got back to us. So yeah.
Okay, so maybe we can try it out for this session, right? So can you give me a 60-second elevator pitch?
60-second elevator pitch.
Yeah, elevator pitch is 60 seconds. Let's see how good you are in convincing us to part with our money.
Sure. So FOR, you know, is venturing into this revolutionary technology of reshaping structures. You know, currently we are able to have this proprietary technology where we can implement in emerging sectors such as space structures, in advanced robotics, soft robotics, medtech, where, you know, currently not many people are able to scalably implement. So yeah, we definitely have an edge in being the forefront of these kind of emerging technologies. So yeah, come and learn more from us, and yeah, work together.
Okay, thank you very much. I hope that the rest of the audience are impressed, and we'll follow up. Now, let me go into, let's say, if you want to convince people to invest, right, you have to prove its value, right? And the proof its value is to let the market accept it. Now you claim what you say. So how actually you prove the value?
So I would say to prove the value, the best way would be to get sales, which definitely is the number one thing. So right now, since we don't really have a full product yet, the way that we have been proving value is through a letter of intent, which is kind of indicative of a product's value. So yeah, I would say that would be the one of the number one things to get if you don't have a product yet. Yeah.
Okay, so the letter of intent is a proxy of the market acceptance, right?
Yeah, you can say that it's kind of like a proof that people are interested and are kind of seriously looking at it. Yeah.
All right. Okay. So I'm going to into something much more sensitive, huh? That means if you want to raise fund, how much you want to raise and what's your valuation? How do you actually compute that?
Well, I would say right now we are not super hard up on getting investment because we want to go through because Singapore has a lot of grants for deep tech startups. So we want to move through and exhaust all those avenues first. So, we think that if we manage to get all the grants that we have, planned out for this year, we could raise easily about 1 to 2 million just based on the grants alone. Then after that, moving forward, it's easier for us to justify our valuations, by saying that, okay, we already have this amount of support from the government, have this much cash on hand. So if you support us, our valuation can be even higher, maybe 2, 3, 4x perhaps.
Okay, so basically you are now in the R&D stage, trying to build up your first product, and then depending on government grants, which of course in Singapore is quite, especially for university technology project, it's quite substantial, quite a bit for you to apply, right? I think the proof of the pudding is that at the end of the day, when you go out in the market, people invest, okay? Because the government may treat it as a R&D project. Now, looking at Mervin itself, right? You see, the technology itself can have a lot of applications, and you applied it to this brace, or in this case the finger part is called the splint, right? I know because I broke my fingers before, so I have to have a splint actually. And then after that, they asked me to do a physio on my finger. I don't know what to do with it. Just keep on taking my fingers. But don't you think that, have you explored other options of applying the same technology, which possibly have bigger market, rather than do on the first application that you experience, or Mao experience, your co-founder experience? What goes through your mind?
Okay. Okay. So honestly, to be frank, okay. So maybe I'll just give like a brief history of myself. So after I graduated, I actually studied architecture as an undergrad, and then after I graduated, I didn't want to pursue architecture anymore. So I was looking into more of engineering postgrad studies. So, and around that time, Mao actually asked if we want to believe this project again, this CAST project. So we applied for this competition in China, and it was pretty well received, and we really wanted to like pursue this even further. And as I mentioned, like we noticed some of the problems with 3D printing itself. I used that as I wanted to pursue my research for this particular application itself. So in a way, although we did explore like some other applications, we were somehow biased towards this because it's our first baby in a way, So yeah, that's to be frank, that is like the main reason why we chose. Like even in terms of like market research and stuff, we basically prioritize this application. But of course, we also looked at other applications. And as you correctly pointed out, there's really a lot of applications that are out there, because we are essentially a manufacturing technology, and manufacturing, you can really look at the possibilities are limitless. And as Abel described, there's like the aerospace, there's the robotics, soft robotics, even food technologies, anything that can be manufactured for a certain application, we essentially can go towards. So yeah, it was a hard time to choose, and we know that we were passionate about this, and basically the research was catered for this. That's honestly why we went on with this. Yeah.
Okay, good. And then let's try to understand your founding teams, right? Let's say Jia Yi, right? And you're doing a PhD, right? Yeah. So don't you want to become a professor?
I pursue PhD because I want to know more about that field, but I myself actually prefer to have my own business. In a sense, I prefer to work for myself. Yeah, I mean, I will try, but well, no harm to try because I'm still young. If cannot, then maybe I will become professor again. But I think we can make it.
Yeah, it's just interesting, right? Nowadays, there are so much opportunities that go out and try, and then sort of do something that is interest to you and passion. So, okay, now I'm going to pose you a question not so easy to answer. All right. Nowadays, people always say, oh, you want to do a deep tech startup, and this is a deep tech startup, right? So you must work towards a unicorn. So how are you going to make it become a unicorn?
Right. So I would say for this, we're gonna kind of segment our manpower well. So currently we do have a dedicated team for the cast, and at the same time we do have a smaller team that kind of R&D's future applications. So right now, for example, one that is on our mind is actually on food printing. So on the side we do some research on the area, find out where we can enter, who we can get in touch with, and that is where we slowly, that's our way of building up our teams, the different segments, because once we get in touch with these parties and they believe in the technology that we have, it is, I would say, it's simple enough to expand into another team, to bring in more manpower, because they believe in that particular, our particular technology, and how we can help each other to really change that particular industry, which in the following case would be food printing. Yeah.
So maybe give us some indications of what are you printing in terms of food, hamburger.
Right. Okay. So I would say what we are planning is some sort of valorizing seafood waste. So we use that, for example, actually shells have a lot of nutrients. So with our technology, we are able to make the textures, we are able to manipulate the textures very well. And we can make, for example, these shells become chewable, for example. So in a way, it recycles the waste, yet you have more forms of nutrition in your food. Yeah.
Okay, so this question is for Abel, right? So you are a management or a business student, right? And then you are surrounded by all these people who speak things that you probably wouldn't know what they're talking about, right? Like Jia Yi and Mervin, right? And they talk and it's like, okay, this is like, okay, great work to me. But then you are a CEO, you got to lead the team, right? You got to bring them charging in the direction. How do you make sure that they listen to you?
I would say, it isn't really much about making them listen to me. Kind of, it's good to have a direction that we all agree upon. Yeah, so we always discuss about where we should go, what we should do next, what to accomplish in this month or next few months. So yeah, I'm glad it hasn't come to any situation yet where we have to argue about which direction we have to take. Yeah. And as for maybe your other question on how I understand their technical stuff, Okay, I'm quite a nerd myself also, so I will go and randomly research on the kind of things that they talk about and try to find out about a bit of the technicals that they are going through. Yeah.
Okay, there's a discussion about the team dynamics here, right? We always have an inclination, and when I work also, like the marketing and the business guy will what we call chong, right? I say, oh, customer say what promise, okay, can, sure, can one. Then the technical guy come back and say, cannot do, or take another year to do. So there will be these things, right? So you want to chong, you want to go to a hospital and the doctor say, can you do this? You say yes. And then after that, come back and say, guys, I just promised something. So how does the dynamics work here?
Right. So definitely we do face this every day. So every week I'll be like, okay, maybe we can get this up. Maybe we can start talking to people. Then, Mervin will come and bring me back down to earth and tell me that, okay, it can't be done yet. It will take, a few more weeks. Then I'm okay with that fact. It's at the end of the day, I'm not the technical person. They will know how far we can progress, but as always, there are other things to lay the groundwork for. Yeah, because there's no sense in complaining that hey, you're going too slow, because I would say that's not how product development should be. We shouldn't rush this kind of products. We should wait until everything is ironed out smoothly. Yeah.
Yeah, I think I can understand because now you're all on grants, right? So there's no pressure.
Yeah.
But when the cash start burning and reducing to zero, what's your plan?
Right. I would say for us, if the cash starts burning, we'll look at our existing product lines that are actually working already. So they are already being easily manufactured. So for those, we will be able to promise more things, and we will be looking at ways to, sell what we already currently have that we know is reliable. We can't kind of force or promise future research to come faster. So I would say that would be the direction that we take when we find ourselves in such a situation.
Okay, so Abel is like saying, okay, you see, I can cater to the tech guys. So can I ask the tech guys, right? Is it true, right? How is working with Abel, right? Is it that he really listen, or is like, oh, this guy always rush before anything can be done? What do you think? No, it's the dynamics, right? Because there are two ways to look at it, right? So especially in an interdisciplinary team, some people say, hey, I learned so much from this guy because we are in different areas. Some people say, this guy totally don't understand what we are doing, and they get frustrated. So how is working with tech guys working with business people from the technical aspect?
Okay, honestly, okay, maybe I'll just talk more on the personality perspective first. So I think on that end, at least me and Abel, we match pretty well. So in a way, I'm a very indecisive person, or rather I hesitate a lot. I think a lot about different options and stuff. And Abel is the one who is like really decisive, and he dreams big basically, which is why, like you mentioned, he keeps pushing for this and that. So in a way, it really matches because of this decisive nature. It also motivates me, and because of my personality, I think a lot and stuff. I will come up with ways to sort of slow him down and tell him, this is probably not the right time and kind of thing. And it's great because he also listens, and I'm not sure if he truly understands, but for now it would seem that way lah. So I would say on the personality note, I think we work pretty well in terms of dynamics. Yeah. Maybe Xiayi, you want to share a bit about your perspective as well?
I think it's good that business people tend to be a little bit more rushed, I guess, because sometimes not sure if it's true, but when people talk about R&D, research and development, right? But some people think it's relax and do also. So in a sense, if it's true that sometimes Abel might a little bit too rush, but then to us, I think it can be a good thing also, because in that way it will motivate us to try to fasten our pace lah. Of course, produce quality stuff also. So to me, I think overall, of course, we still listen to each other as of now lah. But so far so good.
All right. So what do you think will be from your three different different roles, right? What will be, I will just ask one single challenges going ahead, right? One single challenge going ahead, right? For you, right? I mean, now you have grants, but eventually your get funding will run out, and what will be that challenge that you'll be facing for the next 6 months?
Right. I would say definitely the business model is important. It's not very wise to just focus on grants. So I would say my focus now is 50-50 on getting a sustainable business model as well as having the grants. So that's why, we are right now very careful in looking at what kind of manufacturing methods we'll do so that we can scale higher. So I would say both balances out for now. Yeah. Other challenges we face in the future might be deciding on which next industry we will go into, because we do have some I would say small disagreements regarding whether we should go into food printing first or we should explore like hydroponics. So these are the kinds of things that we are slowly ironing out. So yeah, that might be a potentially small challenge. Yeah, but I'm sure that we'll be able to overcome it.
Mervin?
For me, I'm really concerned about like more of the prototyping aspect. I know like there's been some delay for a while, and then I kind of feel guilty about like for the rest of the team because they are like waiting for my progress and stuff. And I think the primary focus recently, like before this, is really get some employees to help us. I really need to like delegate some tasks and get some help on board. And I would think that's the greatest challenge because we will have employees joining us, and then it's more in terms of like confidentiality, whether basically this relationship with employees, whether so basically we got like 2 trainees. The SG United traineeship will be with us for 6 months. Yeah. And then basically 6 months is good. And how much we can progress from there will really will basically be a deciding factor whether they will continue with us after the 6 months. So I would think the challenges is really about this managing these employees, our working relationship, and our progress in the prototyping phase. Yeah.
All right. So how about Tiai then? Finish up your PhD, is it?
No, I mean, yes, I have to finish up my PhD, but also because I've been in charge of the operation of the startup, and then now we start to have, as compared to a few months ago, our prototype is more mature now. So I start to liaise with more and more regulatory people and also QMS people. And then recently I'm going to sign up for lead auditor course. So yeah, I have to juggle between this course and also my PhD. So yeah.
Lots of things to juggle for you, right? So assuming that you are doing your QMS is ISO 13485.
Yes.
Okay. Okay, good. Now is about 50 minutes into the chat session. I just want to end with let's say a message from you, right? How much you want to raise in the next 6 months?
How much we want to raise in the next 6 months? I would say we're looking to raise maybe around 500,000 to $1 million. Yeah.
Okay. 500,000. How much shares are you going to give away? Which of the company are they going to give away?
Right. So
means of valuation. Yeah.
Right. So I would say for this, it's really a range because if we manage to get more grants, that will increase the valuation. So it's not very it's not very reliable to give like a certain range.
Yeah, no, yeah, I understand. Yeah. We never commit until people put the cash on the table.
Yeah.
Okay, sure. But my thinking is that we can do cost-based valuation. It means I believe that's what you're trying to do, right? If you get $1 million grant, means okay, at least it's worth $1 million, and then I just do a multiple on that million. But that's assuming that the million is spent wisely and that
Right.
Right. If $500,000 was like trying to figure out what's the problem, then really it's only $500,000 that is actually got value. So those are some things that people will look into their valuation, but I think a cost-based cost multiple valuation is not something very, very useful to me. As always look at really what's the market is financial projections, and then from there on we discount it, and if we still have a good number, I thought that's probably a better way. But you study business, so you probably know exactly what can be done. Anyway, thank you very much for coming. It's about an hour into our talk, and thanks a lot, and we'll catch up with you 6 months down the road.
Thanks a lot.
Okay, thank you so much, Prof.
Okay,
Neil,
see you.
for having us.
Bye.
See you.
Bye-bye.
Thank you.